Hello, today's video is engine design on that 355. This is part 3, and in part 1 we talked about the actual pencil paper design of what we were wanting to do. In part 2 I kind of talked about what kind of camshaft I would need, and this is part 3. This is where I'm trying to actually start pull the parts together. Now, I got in the aluminum heads. As you remember, the heads that he brought me weren't going to do what he really wanted. It is a basic build. We got in a basic bare head. I threw in a couple of valves. The head was about as expected. Not much different than what I said. Small block is usually not a bit of a surprise. If you're doing a rarer motor, sometimes it comes out more interesting. Had 2-inch cross as expected, and the flow at about 500 lift was 214, at 550 lift was about 222. And you know, it's a regular 202 160 valve. It does take 100 long valves to get stem height correct. It's a pretty straightforward head. This particular head I did buy because it has both the Vortec bolt pattern and the standard early bolt pattern on the head. It's a bit of a universal head. I was somewhat under the impression he had a Vortec intake because that's kind of what we were originally working on. I proved to be mistaken on that. The intake that he has on hand, he hasn't gotten Vortec yet, is actually a bow tie. Looks like it's from a crate motor. It's definitely used. I'm going to have to clean it up. I'll have to check the cross section on it and make sure it's enough. It's basically the bow tie copy of the Edelbrock Performer intake. So it might be a little on the small side. I would have maybe kind of hoped for an RPM maybe instead of a Performer. But we'll look it over. I might even throw it on the bench and let you know what it does once I get the heads cleaned up a little bit more. Now, there was a good post by somebody, and I appreciate such posts, where he talked about, in this particular head, about maybe putting in a 205 valve. Now, I looked over the head, and for the most part, it's a good standard head. I mean, even remember, a lot of the basic heads, even from AFR and whatnot, are all a Chinese casting. They're all the same casting. And this is just a really basic head. You know, we're not talking race runner, we're not talking anything. Basic replacement 202 160 head. That's why I kind of knew what it would do and what its cross was, is I've seen enough of these. They're all the same. So, one of the things he pointed out is that we could go to a 205 valve and pick up in a little bit more flow. And that is certainly true. And looking at the seat area, it's actually not a bad idea, not from the standpoint at first of getting flow, but the seat is less than ideal. The throat size isn't too bad. There is a itty bitty little ridge from where they cut the seat, but that's minutes of cleanup with a sanding roll. Like I said, I'm going to have to increase the cross a little bit. I need this to be just above 2, like maybe 2.05 cross section to support the, remember I need like 220 CFM or so. But I will look at the push rod pinch. My guess is I can probably clean that up a little bit, make it just a little nicer right at that bump, again with not a lot of work, and take maybe like 30 thousandths out from top to bottom across that pinch area, which would get me up easily, you know, probably like 206, 207, somewhere in there, which is above where I'm on cross by just a little bit. And so that would help. The 205 valve I'd have to order out, but it's not a bad idea, because one of the benefits of going to a what's in there is a 202. We're just talking a little bit bigger. But probably the worst thing on this head is how the seat's cut. It's just not great. It's not a good cut. It's just really generic. I mean, if you wanted to throw in a valve in, it would work. It would probably flow what you need. It's kind of designed, standard small block head. You're typically looking, the 2-inch cross can support that 216. The flow about 500 is about that. And that's kind of what they do. Most of the cams that you look at are about 500 lift. And so it kind of all goes hand in hand with a basic build. Now, if I want to increase that a little bit, my original cam design was 234, 244, 112 plus 4, 550 lift. I said 550 lift because I expected this. To get to that 220, I kind of expected needing that 50 thousandths more lift. Now, the cam I found is a Comp Extreme Marine. Number is 212, 244, 4. I'm sorry, 12, 244, 4. It's listed as about 2,000 to 62. Now, we don't have enough air to get to 62, even with a 355, and I've shown that in the previous videos. I'm guessing if they did actually test this cam on a motor, they probably did it with a slightly bigger head than what I'm trying to use. The key on this is that, the basic range is about what I was talking about in the previous videos. So if they did test this, and I don't know if they did or not. Some cams get tested, some are just kind of generalized made. The key would be really that 2000 that I was talking about. That I was watching the overlap and trying to make sure that the bottom end was still going to be okay. And so this is very promising and kind of goes right hand in hand with what I've been talking about when we designed this before I even went out and looked at cams. Now, this is a fairly slow cam. If you look, 278 to 234, 292 to 244. So this is not a fast ramp cam. And I was doing that on purpose because I want the engine to hold up. I want it to not beat up anything. This also reduces my need for a valve spring. It calls for a 981, a basic Z28 valve spring. Now, if I go up to that 550, I might have to go to a little better spring, one that I call like a plus 100, something that's better to almost 600, but the same basic kind of spring as a Z28, same diameter, same kind of retainers. It's just a little different spring. So if we do that, in order to get to that flow, I'd have to look at spring just a little bit, and I'd also have to probably run a bit of a higher ratio rocker. And I could do that. Instead of the 1.5 standard ratio, I could run 1.6. Now, this is a budget build, and I'm trying to stay under 5,000 so that it's very friendly on parts. This is standard rod, standard cast crank, hyper-eutectic piston. It is not a big budget build. And I try real hard not to throw a bunch of money at an engine that is parts it doesn't need. I try and keep it down to where I'm doing. That's also why I try not to increase that airflow. I could go to a slightly bigger valve, pick up more airflow, and that's what the one gentleman posted. But that's going to also push me up in RPM. And I'm really trying to stay in that 2,000 to 5,000 RPM, maybe a little carryover to 5,500. And so I need to watch it. I don't want to overbuild what I'm actually trying to build. That's the whole reason we designed these. So I could go to a slightly bigger valve, but really try and get that kind of flow down here at 500. And that's certainly doable. That'll give me a nicer seat. I can clean up the throat just a bit, clean up just the push rod wall just a bit, call it good, maybe hit my 220 CFM at 500 and just run the cam with a regular rocker arm. Or I could run a 1/6 ratio rocker, which there are some inexpensive ones, though you have to watch because some of the inexpensive roller rockers are actually not the ratio they say. So you will need to double check and make sure you are getting the lift you think you're getting. But I'm thinking more in the way of maybe a stamped steel. I mean, they're $70 a set or something for a 1/6 stamped steel rocker arm long slot, which would certainly work if we keep the spring rate down, which is part of the reason I was trying to keep this friendly, is I don't want to have trouble with push rods or rocker arms or any of that. I want it to hold up and do what it's supposed to do. I mean, it should drive decently, it should sound right. This did say it had a slightly rough idle, which is exactly what we were looking for, what we talked about. So, like I said, what Comp said about the specs that we figured out is pretty much on par with what we were expecting it to do. And that kind of shows you that the way I was showing you and talking about it is actually fairly accurate, because I didn't look this up until we had figured this out. And so it's not like I did it ahead of time. In fact, I had to search a little bit because Comp doesn't tend to like 112. They like 110 lobe center, and that's part of the reason I wound up in the marine section to try and get that 112 lobe center. So that's kind of what we're looking at, and I'm not quite sure what I'm going to do. I will clean up the head a little bit first and see again how it flows before I make a final decision on getting the cam. But I'm trying to pull all the parts together. The head is very straightforward. It takes standard guide plates, standard studs. Like I said, it's nothing special in the way of a head, so we don't need to worry about it. I may have to worry about the intake and talk to him a little bit about that. And the first thing I want to do is really sort the head out a bit and see if I can get this flow up, even maybe with the 202, in order to not have to do rocker arms. I could use the standard rocker arms he already has that are 1/5 ratio. And so that's kind of how it goes when you start pulling the parts together. You can find what you're looking for. You have to slightly maybe refine it a bit once you start pulling it together. But I also want to, like I said, make sure you don't overbuild. Because, I mean, even the machinist that does most of the work at Cavco, Mario, was like, oh, well, we put in a bigger valve, we get more flow, we throw on a, Victor Jr. and really make some horsepower. Well, that's possible. And even kind of with the parts we're looking at, that's possible. But the RPM is going to move up. We're going to sacrifice part of that 2,000. And that's not really what the engine's about. And it's easy to get, I want more power. Especially when you run the dyno, you like seeing things that do better. Because the generic stuff that we do on a regular basis is like, it's like, yep, just another engine. And so sometimes you like to see something do a little bit better than what the basic design really calls for. And you've got to kind of rein yourself in and make sure that you're sticking to what you designed and what you planned. Like I said, I like this camshaft. It fits exactly what I was talking about, with the only difference being lift. Now, if I'd done it in a roller, I could have gotten that kind of lift, but that's going to add more money to it. And like I said, I'm trying to keep this as a very simple build, so the only glitch we have is I either need to make it work at 500 lift bump that up, or I've got to try and raise the lift a little bit with a slightly higher rocker ratio. And so that's kind of how it goes, because I have a goal to meet, and that's what I'm trying to do. 400 horsepower, 2,000 to 5,000 decent power band, little carryover, maybe 55, and I think we'll be good. So that's where I'm standing at the moment. I will keep you updated on the head. I'm kind of thinking this is the cam we're going to put in it. I will have to talk to the person that's having us build this once I get a little further on the head. I will do a quick job on one port and see where I stand. I can go back. It's not going to be a lot of port work. He's not paying for a full port job. I'm just trying to clean it up and have it meet the goal of what we're doing. And like I said, some of it, the bull work is literally minutes of work. And if I have enough room at the push rod pinch, which usually that wall is, 60 or 80 thick, as long as there's no weird cord shift. So I should be able to pull, 30 out of it without any big problem. And that's right at the push rod pinch round. And so it's an easy spot to get to, and it's easy to take down. It's again, not a lot of work. And leave it at that. I'm not talking about big bowl work. I'm not talking about spending, a week working on the head. He's not paying for that. And I'm just talking about a little cleanup so that I meet the goal. And like I said, that's where we stand. And I'm just trying to update you. This is part 3. There will be several other parts in this particular section. As always, I wish you well on your projects. And I've gotten some good feedback, which I appreciate. And even the gentleman that posted what he did to get more out of it, I appreciate that. And the other guys that read it can kind of see what your options are. Because I don't always bring up that, there is more. And there's always more. Making horsepower is not the hard part. You can always make more. Trying to make it where you want with the given CID, well, that's a little more challenging. If we were really to want to pump up the head a bit, I would probably prefer it to be on a 408. Something with a little more cubic inch and keep that RPM down to where it's more of a sensible engine. Because remember, this is a street rod. It's going to drive around normal. Even if it has, I'm not sure what gear he'll put in it, but let's say he goes up to even 355 gear. He would still be able to drive it because he's still going to be down here in the RPM. Like I said, a little bit of gear, even a 308 gear, and a little bit of torque converter, nice 2500, get you up into the power if you really stand on it, but not generate a lot of heat, because that's one of the problems. You put in a big converter and you start driving around down here, then you wind up having to do a better tranny cooler and all that, because that converter, when it's slipping, is generating extra heat, and you got to deal with that. And street rods drive around. I mean, they're in parades, they're driving into shows, they're cruising around to be cool. You want it to sound rumpity rump, you want it to pull okay, but you also need it to drive nice. And you've got to remember that point when you're working on the design, so you don't get carried away. So anyway, I know I rambled a bit. Again, this one was just off the cuff, keeping you updated. And we'll talk to you later. Bye.